So here, that's the conclusion slides to try to raise some points about the comparison between the MCK way of recording data, if you wish, and the waveRAPID method. So here it's a comparison of time that has been spent on setting up the experiments as well as running it on the machine. You have to see that's a comparison to reach the same level of information. So we want to have the K on, the K off, as well as the affinities. For that, in the traditional MCK, you would have to do, first at the preparation stage, you would have to do serial dilutions of all the different compounds, which is actually time consuming compared to the waveRAPID, where you use only one stock of the compound. And although one very important point is that the space that you have on the rack, of course, if you do 8 different dilutions of each compound, you cannot screen 42 compounds in one go, while with the waveRAPID you can. And although affecting the measurement time tremendously, so I was very astonished to see the difference. So that's a rough calculation, but for the waveRAPID run for this peptide screen, it was in total 12 hours and a half for one run, and we got all the information we wanted. If you would have used a traditional MCK, and if you would have to really measure accurately all the parameters, you would have to do 3 successive experiments because of this space problem on the rack, that you cannot measure all of them in one go. So first you have to assume that your protein will be stable for 3 different successive experiments, which is not always given for membrane proteins. And that would represent approximately 70 hours of experiment on the machine. So you have a factor 6, let's say. So 6 times faster for the waveRAPID compared to the traditional MCK. And although one very important point is that you consume much less reagent. So for example, for this waveRAPID experiment, this screen, I used 250 ml of buffer. While for the traditional MCK, I would have to set up 3 different experiments, and that's close to 1 liter of buffer. That doesn't sound much, but for us it's very important because in the reagents and in the running buffer, we have very expensive reagents sometimes. So like detergents, or sometimes we put compounds in the running buffer. And of course, if you can minimize that, I mean, it's always helpful. So this was for the time-saving part, which is very important for us. So that allows us to really improve our lab productivity, but although, as I show you with the last example, that allows us to combine the primary and secondary screen. So in one go, we get all the kinetic data, K on, K off, and KDs for all the compounds. And combined to the software that Creoptix has developed, we have although a better assessment of oddities that you can have sometimes, especially for weak binders in the association curves, for example. So altogether, that gives us a very nice, fast, and reliable system to really assess all the different binders we might have on membrane proteins.